Now, for the feature presentation. Pituitary gland, the master gland. The pituitary gland. As you can see, we have capillaries, arteries, veins, portal system, the enix, the neurocirculatory cells, the posterior lobe, the anterior lobe, and the pituitary fossa. The pituitary gland is a pea-sized gland located at the base of the skull between the optic nerves. The pituitary gland secretes hormones. Hormones are chemicals that travel through our bloodstream. The pituitary is sometimes referred to as the master gland, as it controls hormone functions such as our temperature, thyroid activity, growth during childhood, urine production, testosterone production in males, and ovulation, and estrogen production in females. In effect, the gland functions as our thermostat that controls all other glands that are responsible for hormone secretion. And this is why we're the most important gland in the body. The gland is a critical part of our ability to respond to the environment, most often without our knowledge. Hormones secreted by the master gland. The anterior pituitary secretes ACTH to the adrenal cortex, GH to the muscles and bones, MSH to the skin, TSH to the thyroid, gonadotrophins FSH to the testes and ovaries, LH to the testes and ovaries, prolactin to the breast by the posterior pituitary, oxytocin to the breast by the posterior pituitary, and ADH by the posterior pituitary to the kidneys. Hyperpituitarism generally causes hypertrophy and hyperplasia. Hypopituitarism leads to hypertrophy and hyperplasia. Adrenocorticotrophin, ACTH. ACTH stimulates the production of cortisol by the adrenal glands. Cortisol, a so-called stress hormone, is vital to our survival. It helps to maintain blood pressure and blood glucose levels. Adrenocorticotrophin, ACTH. Hypersecretion leads to Cushing syndrome. Hyposecretion leads to Addison-like syndromes. And as you can see, the molecular structure of ACTH at the bottom of the slide. Growth hormone, GH. Growth hormone stimulates growth in childhood and is important for maintaining a healthy body composition and well-being in adults. In adults, it is important for maintaining muscle mass as well as bone mass. It also affects fat distribution in the body. Growth hormone. Hypersecretion leads to gigantism. Hyposecretion leads to dwarfism. Again, the molecular structure is at the bottom of the page. Melanocyte stimulating hormone, MSH. MSH stimulates the production and release of melanin by melanocytes in the skin and hair. MSH signals to the brain have effects on appetite and sexual arousal. Melanocyte stimulating hormone. Hypersecretion leads to darkening of the epidermis, and hyposecretion leads to lightening of the epidermis. And the molecular structure is at the bottom of the slide. Thyroid stimulating hormone, TSH. Thyroid stimulating hormone stimulates the thyroid gland, which regulates the body's metabolism, energy, growth, and nervous system activity. This hormone is also vital to our survival. Thyroid stimulating hormone. Hypersecretion leads to Graves' disease. Hyposecretion leads to mental retardation. And again, you can see the molecular structure at the bottom of the slide. Gonadotrophins. Follicle stimulating hormone, FSH. Follicle stimulating hormone promotes sperm production in men and stimulates the ovaries to enable ovulation in women. Luteinizing hormone, LH. Luteinizing hormone regulates testosterone in men and estrogen in women. Luteinizing hormone and follicle stimulating hormone work together to cause normal function of the ovaries and testes. Follicle stimulating hormone, FSH. Hypersecretion leads to decrease in sperm and ovum production. Hyposecretion leads to male and female infertility. Luteinizing hormone, LH. Hypersecretion leads to menopause and testes failure. Hyposecretion leads to abnormal sexual function. And again, the molecular structure is at the bottom of the slide. Prolactin. Prolactin stimulates milk production from the breast after childbirth to enable nursing. It also affects sex hormone levels from ovaries in women and from testes in men. As you can see in the picture, the breasts are enlarged as the mammary glands have been engorged with milk. Prolactin. Hypersecretion leads to absence of a period and excess milk production. Hyposecretion leads to failure to lactate postpartum. Oxytocin. Oxytocin is best known as the hormone of love. Oxytocin is known for roles in female reproduction. 1. It is released in large amounts after distension of the cervix and uterus during labor. And 2. After stimulation of the nipples, facilitating birth and breastfeeding. Oxytocin. Hypersecretion leads to induction of labor. Hyposecretion leads to extreme anxiety. Note the molecular structure at the bottom of the page. ADH, antidiuretic hormone. Antidiuretic hormone, also called vasopressin, regulates water balance. When normal amounts are sent to the kidneys, increased water reabsorption occurs. This yields concentrated urine. Antidiuretic hormone. Hypersecretion leads to syndrome of inappropriate antidiuretic hormone, which can lead to fluid overload. Hyposecretion leads to diabetes insipidus, which causes extreme thirst.